Good evening, everyone. So I'm Dr. Yao. I'm in charge of the AMC organization in Hong Kong and Macau. So for this year's AMC 8, the official competition period is from November 10th to November 16th in US time. So I understand that most of you in Hong Kong and Macau attend the competition on November 11th. And so now the official competition period for the whole world ended. So we could have a live discussion to discuss about the score statistics as well as some challenging problems in that math competition. And so the first page, so I show the statistics for participants in Hong Kong and Macau. So we have nearly 900 students that attended the competition. And it's good that we do have one student who gets a perfect score. And our average score is 11.47. And also the median is 11. So it's roughly, so if you learn statistics, you know there's normal distribution. It's roughly a normal distribution besides the two lower scores and maybe the three higher scores. And so I would suspect the shape for the score distribution in US and Canada would be very similar like the situation in Hong Kong. But of course, I just finished the session for the discussion in mainland China, and the score distribution would be slightly shifted to the right. And hopefully, gradually, we could see that our Hong Kong statistics would become better and better in the future. And some of you may know that for the AMC 8, besides the participation certificates, there will be three key awards. The one award is for the top 1% of overall participants, and the next award would be for the top 5%. And besides that, there's also a special award for students in grade 6 or below who have achieved 15 points. And for this top 1% and top 5%, the cutoff score is cutoff scores are varying year by year. And last year, the two scores are quite high, it's 23 and 19. And for this year, by the statistics in Hong Kong, so that two numbers would be 21 and 18. So 21 for the top 1% and 18 for the top 5%. So this is by the statistics in our region. But what would be the statistic in US and Canada? We don't know yet, and we'll see. But I would guess it was quite close to that two numbers. And so that is a score distribution. So that's the overall situation. And then we look at the individual top performers. And the next page shows the top two. So we have a perfect score from DBS, and we have a 24 from HKIS. And actually last year, Sebastian achieved full score in AMC 8. And also, if you Google this person, so as I was notified in the afternoon that actually he attended the International Mathematical Olympiad for this year. So both are quite strong students. And then we move on to the next page. That are the people who have achieved 22 and 21. And there are also, so these students are from DBS, HKS, but in addition to that two schools, we also have people from Melbourne College, Singapore International School, and SF. So that's 22 and 21. So the next page would be 20 and 19. Of course, there will be more and more people within the same score. And also here we have people from German space and some other local schools as well. And also the DGS. Okay, so that's 10 and 20 and 19. So the names are listed by alphabetical order, so it's easy for you to to check. And so the last page shows the students who have achieved 18. And I do see that there are some students actually in this page are in primary schools. And so that are the top, basically the top 5 performers in Hong Kong and Macau. And you don't need to worry. And we are going to list all these names in our WeChat official account, so you can see it carefully if you want. So that's the top performers. And next we'll see how we behave in each individual question. And of course, the beginning problems are easier, and there are some difficult problems. So the most difficult problems for us in Hong Kong and Macau seems to be that 3 questions: 22, 24, and 25. And there are also some relatively low bars, which are these 2, right? And that's 3. So these are the 8 questions that we are going to discuss today. So basically what I'm going to talk about is I will tell you what is my response or what is my way to solve these questions when I first saw them. So we will start with the most difficult ones. And the one with actually the lowest correction rate is the last question. And the last question actually contains not that many components. It contains what? It contains 3 squares, so named by S1, S2, S3, and it contains 2 rectangles. So they're basically 5 mini shapes, and they mingle together, they put together, they form a big rectangle. And now what are the numerical conditions? There are 2 numerical conditions. One is that the width as y width is 3322. So this is 3322, and the height is 2020. Right. These are the 2 numerical conditions. Okay, so these are the big rectangle. So the question is asked to ask what is the side length of the middle square. And for me, when I first see this question, of course, you ask about the size of the middle square. So you should think these side lengths as one variable. What are our one unknown? What are the other unknowns? So giving that, so there are 2 other squares, so there will be 2 side lengths, but for rectangles, because there's width and length. So essentially, for the unknowns, we have 1, 2, 3, and then 4, 5, 6, 7. We have 7 unknowns. So actually, that's quite a lot. But given that we only want to know the side length of the middle square, so my idea is, how about we just first assume the 3 side lengths, the squares as A, B, C, and see how it goes. If you write A, B, C here, actually, if you look horizontally, you look at the horizontal line segments, what do you see? So this is A is here, B is here, C is here. But we can shift it up because it's a rectangle, right? So this part must be B plus C, right? Okay, so then we have a nice equation. What? A plus B plus C must be 3322. So A plus B plus C, that is 3322. Okay, so we get one equation. Then what to do next? I think a better way we do is we just consider the situation for horizontal. So the next part would be vertical. So how we denote this 2020? Okay, 2020 is here. We do have a C because that's a square, but we don't know this bit, right? How to deal with this bit? This bit we can move back to here. Okay, here, that's trivial. This is A, and we need to deduct B, right? So this must be A minus B. Okay, so we have A minus B, we have C, okay. So we get A minus B plus C. That equals 20, 20. Okay, All right, so that's nice. Okay. Then what we want to know? We want to know B. But you see, A is here, appear twice with both positive signs. So here is C with positive sign. So what we do, the best way to do is you just take a difference of the two equations. One is plus B, so they have a bigger number. The other is minus B, they have a smaller number. So you take the difference, you get what? You get 2B. Then the other side would be 3, 3, 2, 2, minus 2, 0, 2, 0. And the result is just 2B equals what? Equals 1, 3, 0, 2. And you deduct everything by 2. You divide everything by 2, so you get 65 times 2 is 130. 2 times 2 divided by 2 is 1, so 651. So you see, then we finish it, right? So now let's solve this. This is the last question and also the hardest question for us. Okay, so after we solve this question, so in order to make sure that you fully understand it, I will change the question a little bit to see whether you can get it. Okay, so now is my modified question. I will use the red letter and write it here and to make it clear. So what is the largest possible side length of the first square, S1? So for S2, we know the value is fixed. But for S1, the value is actually not fixed. Then, can you tell me what is the largest possible value for the set length of S1? So if you know the answer, can you type it in the chat channel? And maybe I will give you 1.5 minutes, same as AMC 8 question, to see whether I can see some correct answers. So now half a minute passed. I see one answer. Okay, so 1 minute passed. I see quite a few answers. And okay, so I do see quite all right. So the most the common answer I see, maybe I will use a green color, is that number, which is 2671. Why is that? I can understand because you know that B is 651. So what we have? B is 651. Either you minus 651 from that number, or it's probably easier you just add up this 651 on 2020. Then you will get A plus C equals what? Equals 671. And then see, okay, so the minimum case is C equals 0, and then A is 260, and then C is 2000. Sorry. So you think C is 0, and then A would be 2671, right? But can C be 0? If C is 0, you see, then this becomes a point. How come we can form such a thing? Obviously, S3 has to be greater than S2, right? So what does it mean? It means S3, which is C, has to be at least 652, right? So C has to be at least 652. So if C is at least 652, then what would be A? So A is actually, you need to deduct 652 from 2671. So the correct answer actually, I think, should be 2671 minus 652 is 2019. Okay. And that is the correct answer. So you see, that is how, when you do a question, now you already attended AMC 8, probably you already checked the answers, and you know that. It looks like this question you already solved. But you see, once I change the question slightly, it could become a very hard one. And it could give you more thoughts on exploring the more features of such a picture. Okay? So that is our first question. So now we move on to the next one. The next one is again kind of like a geometry problem. And that question is very, very long. And I won't read this question again, but from the picture, for geometry question, you just look and try to understand from the picture. The picture is quite clear. You have a bunch of gray squares. All the gray squares are of the same size. And then it's kind of like we have some borders between these gray squares. And all the borders, all these borders, or you can think this as, we think the gray one as kind of like grasses. This kind of like paths in a park. They all have the same width. Right? Okay, so that's roughly the basic picture. But now we are dealing with the 24 case, which means there are 24 square gray squares. Okay, so what the question is asking, what is the condition we have? The condition we have is 64%. So the gray part is 64%. And once you see 64, for me, the first thing I see 64, I feel happy, right? 64 is 8 square, right? So in other words, because we are dealing with the areas, and we know that we have to deal with the squares. But the first thing I see, okay, 64 is 0.64, right? Another way to see is it's actually 0.8 squared. Okay. So, okay, 0.8 squared, then what does it mean? 8 squared. So then immediately in my mind, once after I notice that 64 is 8 squared, in my mind I immediately have such a picture like that. 10. And then I cut out a border out of this big square. And suppose this is a gray part, because I don't have gray pen, so I have to use the shaded region to denote the gray part. And then the border is 1, 1, 1, 1. And in the middle, that's 8 times 8. Okay, cool. That's great, right? And then that's 64%. Then I see what the question is asking. The question is asking d over s. D over s is like 1 over 8. Why is that? There's something wrong. But then you think, oh, there shouldn't be 1, because when you cut it off, this will be half. There's another 1, because for the middle part, you need to share by the 2 gray squares. So it's 2 over 8, right? So it's 2 over 8. And then it should be B. Okay, it looks like we finished, right? It's very quick. You don't really need to do anything. But actually, that's the reason, one reason that I think this year's AMC 8 questions are the AMC cutoff scores will not be very high is because although the questions are not that difficult, there are lots of traps in these questions. For example, one of these would be that. And actually, the correct answer is not B. B is wrong. And why is that? This is because when you cut off, so this is a complicated situation. You want to see the baby example, so you have to cut, right? But then you cut, you see there are some special cases. You can cut it along the middle line of all these white blanks, and then, but then you see once you cut for this corner, you see this, the weight of this is actually D, but here it's half D. So in this case, when I cut into 9 pieces, these 9 pieces are not have different shapes, right? This is one, this is the second one, this is the third one, right? So you cannot really just change this question into a simple one, then directly get it. So which means there's no way that we have to form kind of an equation to clearly write down all the squares for the case that n equals 24. Given that I don't have enough space in this page, so I'm going to have to flip into the next page, and I will only show you the English questions, and then we start to do the calculation. So in order to find D to S, but let's write down this condition about 64%. All right, so where's D, where is S? So the border is D, so here's D, here's D, 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 and the side length is S. And as you can see from this simple picture, you have 3 grid squares. Then how many wide parts do you have? The three grid squares, you would have 4 vertical wide parts. So now the situation is 24. So you have 24 squares. So that would be 24S. Then how many gaps are there? It's not 24, but 25. So 25D. So that would be the side length of the big square. And then you take a square. Okay, so that would be the total area. And then let's try to count what is on the top, which means the grid part. So how many grid parts are there? The grid part, of course, that will be, you can write down 576 grid squares, but we'd better write everything in terms of squares, and then we can break down. So what I should write is I should write 24 squared. This is number of the grid square, and each grid square has area S squared. Then we get 24 squared S squared. Okay, what is that? That is 64%. For the 64%, I already split this, I already expressed this as 0.8 squared. But now, given that we have a fraction here, so I'm going to write this as a fraction squared. And that fraction would be 4/5 squared, right? Okay. So now we have this. After we have this, what's next? The next step would be trivial, which is we just break down the squares to make the situation a little bit simpler. So get rid of the square everywhere. So we get 24S over 24S plus 25D. That equals 4/5. And then for this, what's next? What's next is you do a flip. Why I do the flip? Because if you don't do the flip, you cannot do any cancellation on this plus sign. But after you flip, you can cancel out. So 24S plus 25D over 24S equals 5/4, right? And then we do have something which is 1, right? 24S over 24S is 1. We can cancel out this 1 from this side as well. Then what do you get? You get 25D over 24S. That equals 1/4. So what's next? Of course, you know that if A over B equals C over D, then AD equals BC, then you can get an expression. But the better way is let's do the cancellation first to reduce the number as small as possible. 24 and 4 has a common. denominator has a common factor 4. So you can cancel out this 4, you get 1, and you get 6. And once you get that, then you see the situation becomes trivial, right? So what that means is 25 over 6 times d over s equals 1. Then, of course, d over s would be just 6 over 25. Okay, so finished. And so we know that this question, the correct answer is A. Right? So that is this question. All right? Now let's move on to the next one. The next one is again a very long question, so that I can only show the English. Yes, some people complain that the screen is still too small, but the good thing about the small screen is, you see, I will try to solve each question within one screen. And for AMC 8 question, right, you only have 96 seconds for a problem, and probably it takes you 20 to 30 seconds to read the problem. So you really only have 1 minute to solve a question. So you have to write down your scratch, your calculation process in a very efficient way. Right? Okay, so this question, what this question is about? This question is about some operation. The operation is once you have an integer, you can either divide it by 2, or you can multiply by 3 and then add up 1, right? So for this process, what you can, from this example, you see the numbers can go bigger, it can go smaller, and this can go up and down. And the question is asking you that for some number, after 6 steps of calculation, it goes to 1. And what are these numbers? And from the intuition, you will know that these numbers cannot be very big. If it's very big, then probably you cannot really get such a small number 1. So what you need to do is, you cannot check 1 by 1. That's too complicated. Because you know for this 7, even you check, you cannot get 1. So the better way is definitely, you know that for sure that the trick is you work reversely. And so you work from the right to the left and to see what are the possible middle steps, and then finally you get n. And given that we have a very, all the questions occupy the screen, so I have to flip into the next page, just show you the key thing in the question, and then we start to do our calculation. And in this calculation, this question is again has lots of trap in it, because they ask you to find all the possible integer n. If they don't just ask you to find 1, actually there are more than 1 solutions. And basically, if you miss 1, then you miss this question. All right, so how to achieve that? Then that means we need to calculate in an organized way. And that organized way is you can draw a tree diagram. So let's explain what does a tree diagram mean. It's just like 1 is the root of the tree. So you see this is 1, right? So who can give 1 after 1 steps of this operation? It can only be from 2, because 3n plus 1, n is a positive integer, 3n plus 1 is always greater than 1. So the first step, or not the first step, or the last step in this calculation process must be 2 to 1. And similarly, for the second to the last step, and in our analysis will be the second step, it must be 4 to 2. There cannot be other choices. However, now in the next step, we have something. We have what? Because we need to have 4, and this 4 is 3n plus 1. So it can come from 1, and it also can come from 8. So 1 times 3 plus 1 is 4, and then 8. All right, okay. Now what's next? What's next? This along this branch that's easy, right? It must be 2. It must be 4 again, right? Okay, so how many steps now? 1, 2, 3, 4, 5. Okay, cool. And once we have this 4, you see you have 1 and 8, right? Okay, you know this is 1, this is 8. Perfect. Okay, so now what's next? What's next would be 8. 8 is not 3n plus 1 format, right? It has remainder 2 when divided by 3. So the only possibility to get 8 would be 16. However, for 16, 8 is 3n plus 1. 3 times 5 plus 1 is 16. So it can be either from 5 or from 16 times 2, which is 32. Five and 32. And for both 5 and 32, you know that it cannot be, it is not in the 3n plus 1 format. So they must come from the double of these numbers. So that would be 10, and that would be 64. Okay, so now what's the next step? The next step is you add up all these possible numbers. What are the solutions? The possible n is 1, 8, 10, 64. You add all of them together. 74 plus 8 is 82. 82 plus 1 is 83. So that is 83. And then once you know 83 and you select E, and you know that you must be happy because it cannot be bigger. You already get 4. You know, there must be, you must miss nothing. All right. So, okay. So that is 22. And now I'm going to take a rest for you to solve some problems. And what is the variation of these problems? So now in the original problems, we have 6 steps. And now if we have 7 steps, what would be the answer? The sum of all possible value of n. Again, let's try if we can solve in 1 minute and a half. So this, I just want to make sure that you understand the whole procedure. Okay, so I see the first answer in 30 seconds. Okay, so in the next 30 seconds, I see 2 different answers. So now we have 3 answers. Okay, more answers come out. Okay, so now it's 96 seconds. So I see roughly I see about 10 answers, and it's good that the majority of the answers are correct. And the first answer came from Tom, which is super fast. And actually, we do can, if you fully understand this procedure, you do can solve this question super fast. Why is that? Actually, you don't really need to check one by one. And you know that I will change the color. For all these numbers, so now by the 6 steps, you have 4 possibilities. By all these 4 possibilities, definitely you can double them, right? Because you double them, you always get a possibility, like 2 to 1, something like that, 16 to 8, and so on. So then what you really care is, you double them, you always get that number. Is there any other possibilities, which means, are there any 3n plus 1 numbers so that you could have another possibility like this? And then you know that, yes, we do have, right? So this is not 3, this is 3n plus 1, but that's too small. This is 3n plus 2, and that is 3n plus 1 type, so you could have a 3. And here is also 3n plus 10 type, you could have a 21. So what you do, you just add up this 24, on top of that, right? Then that's it, which is 166 plus 24. That equals 190, right? So this is actually what is a formula called recursive formula. So make full use of the result that you already achieved, right? You already add up these three numbers. You know that it is three that can help you solve the minute questions quicker. Okay. So where did this question come from? This question actually came from a famous conjecture, and that famous conjecture is states that for any positive numbers by such steps a few times, you always achieve 1. And actually this, if you still remember that from the 7, what we just get is with 7 comes to 26. But you operate on 26 a few more times, it will reach 1. But even for now, and I think this is named by, one of the name for this is called this Collette's conjecture. This is the graduate students who find out this construction. And of course, this is also called 3n plus 1 conjecture. And I remember when I was a primary school student, I noticed that. But even now, many years passed, we still haven't solved it yet. So that's a famous number theory problem. So the statement is very simple, but it's very hard to solve. That sometimes is the beauty of mathematics. Anyway, we cannot solve. We definitely cannot solve this conjecture now, so we move on to next questions. That becomes geometry again. And that geometry is related to circles. And for circles, what shall we do? And again, I won't repeat the question. And roughly from the picture, you can see, okay, roughly speaking, there's a rectangle inside a semicircle, right? That's the basic construction. And for me, for this question, I want to show you two methods. The first method is a typical trick or a typical way that we should analyze a circle is by its center. So how the circle is formed, right? You fix a point and then you have a radius and then you draw it, right? Then you have a circle, right? So for all the circle problems, as I said to students many times when I talk about circle problem, is always try to locate the center and draw the radius. That's a very useful trick. So what do I mean by that? Locate the center. Of course, the center is in the middle of it. So that would be the center, right? And draw the radius. Where's the radius? This is the radius. This is the radius. But actually, there's two more radius because the radius is from the center to any point on the circle. So this is the radius. Okay, so now how can help us? So this must be the middle point. So 16 is divided by 8 and 8. Okay, so then do we know the radius? This is the radius. So the radius must be 17. Okay, so you have a radius, and this here you have a rectangle. Rectangle, that means what? There's another typical structure, which is this is a right triangle. And for the right triangle, you know that a squared plus b squared equals c squared. There's a Pythagorean triplet, and you have 8, and you have 17. Then do you know the missing one? Of course, the missing one has to be 15. So these are the common. We know there's a bunch of common Pythagorean triple. The smallest is probably 3, 4, 5, and then of course you can double the 3, 4, 5, you get 6, 8, 10. And then the other one is we 5, 12, 5, 12, 13. And then the next one probably would be just 8, 15, 17. Okay, so you know that this is 15. And once you know this is 15, of course, the area 15 times 16, so A is the correct answer. Okay. So that is one method. And what is the other method? The other method is actually the way that when I saw the first question that I do it is, so I think about the double, right? I don't like semicircle. I like circle. I like full moon. So let's double the half moon into full moon. Then what do we have? So I'm not that good drawing circles, but I will try. So this is a full circle. And then we have a semicircle, right? So the radius cut this full circle into two semicircles. And here what we really want is we really want this length. And then because we double everything, so if we extend this, we will get symmetry. So this will be x, this will be x. Okay. And then what else? And you know this is 9. And you know this is 12, 25, right? Which is, actually this 25 comes from 9 plus 16, right? 25, okay. So once you have such situation, this is actually a typical structure. What's the typical structure? This is called the intersecting chord theorem in a circle. So within a circle, if you have two intersecting chords, then this times that equals this times that. In other words, we can quickly have a quadratic equation. X squared equals 9 times 25. 9 is 3 squared, 25 is 5 squared, so it's 3 squared times 5 squared. So what is x? X would be just 15, right? So if x is 15, then okay, then we finish, right? Okay, so that is a geometry problem. All right. And then we move on to the next one. So next one is a very short question. So it only has essentially has one line. And this one line asks you among the factors of 2020 for any among the factors of 2020, how many have more than 3 factors? So then that means we need first maybe to get how many factors of 2020 are there. So for 2020, hopefully, before you sit in the classroom to do your AMC test, you already have these things keep in your mind, which is a prime factorization of 2020. So 2020 is even number, it's not only even number, it's multiple 4, so it's 2 squared, and it's actually times 505, which can be split as 505 times 101, right? Okay, so this is the prime factorization of 2020. And for this 2020, what shall we do is how to find the factors of 2020. And you know, because it's a factor, so it has to be, so when you use 2020 to divide that number, it has to be divisible. So for any factors 2020, it must kind of take this kind of format. So what format? It must be in the format of 2 to the power of something times 5 to the power of something times 101 to the power of something, right? It must be in this kind of format. There cannot be anything else. So what are these formats? Then the format has to be, so what could be the exponents here? And it cannot be too big. If too big, it cannot divide 2020. So the only possibility you can see in the power would be, this could be 0, 1, 2, but it cannot be 3, right? For 5, it could be what? It could be 0, 1, but no other possibilities. For 101, it could be 0, 1, no other possibilities. That's it, right? That's all the possibilities. Then, how many factors are there? Then by the multiplication principle, we know that the number of factors would be just what? Because for the first component, there are 3 choices, right? For the next component, there are 2 choices. For the next component, there are 2 choices. There are 12. Of course, you know, you can summarize my analysis, my analysis into a formula for the number of factors in any numbers, and probably you already learned that formula. It's fine. That's fine. But you know that altogether there are 12 factors, and among these 12 factors, we need to find the number that have more than itself has more than 3 factors. So what shall we do? When you see the number 12, you should feel happy. Why? Because it's a relatively small number. So worst case, you just list all of them, you should be able to get it. Okay, so even if you want to list, so we already have a pattern how these 12 come from. So that means we can try to list in a very nice way. So to help us identify the good factors in the sense it has more than 3 factors. So it has to be relatively large. So suppose we have the situation like that. It's 2, 0 times something. That means there's no 2, right? There's no 2, you see, the 5 and 1, 1 both have to be appear. Otherwise, there are only 2 factors, right? So in this case, there should be only one possibility, which is 5 times 1, 1. But if we have a factor of 2, what does it mean? It's getting better because this we can have a choice of either 1 or 2. So here in between, when we construct numbers using 5 and 1, 1, we only need to make this constructed number within that part to have at least 2 factors, and that should be good enough. So 2 factors, any number have 2 factors besides 1. So actually we could have 5, it could be 1, 1, it could be 5 times 1, 1. It could be 3 cases. Okay, so there now we have 4. Then what about the next case? The next case would be still like 2 to the power of 2. Then that's even better. There here, 1, 4 already have 3 factors. So for the middle one, for the things inside, it could be what? It actually could be the same. It could be 5. It cannot be 1 because 4 only have 3 factors. It can be 5. It could be 1, 1. It could be 5 times 1, 1. So there are another 3 cases. So altogether, add up, what is the result? 1 plus 3 plus 3, and the other is 7. And B is the correct choice. So that is a number theory problem. So when you see when the numbers are not so big, you can just use the enumeration method to solve it. All right, now we move on to the next one. And for this question, it's actually a little bit hard. And the reason why it's hard is that first you need to understand what the question is talking about, and then you need to count how many all the possible different ways. And so how to describe a parse? They see the parse, it's going this way and going from P to Q. You see they all appear only in the white squares. And also each step, why is 7 steps? Because each step is actually kind of jump up by 1 floor, right? So this is from the first row to the second row and third row, fourth row, and so on, right? So vertical wise, it's quite certain, but it's only the horizontal wise, it can be shifted left to right and so on. But overall, the overall result would be goes from P to something Q, which is on the right of P. So that tells us that when we write if we want to use some symbols to denote this part, so what's the best way to denote? We can use left and right, use L and R to denote them. Then that can make things become considered kind of like algebra. So for to do that, so for this note, I will do that. So P first going up and right. So I will write R, and then next you'll see left, so I have 2L, and then right, so I have 2R, and then left, and then right? Okay, so for each part, we can use a letters of L and R to denote it, right? And if we have such letters, then what we have? You see, by this example, you see what happens? We have 4 R's. We have 3 L's. Why is that? Because R is kind of like, if you have a coordinate plane, right, in this direction for X, R kind of like plus Y, right? So L kind of negative Y, yes. So altogether, it has to be shifted right. So 4 minus 3 is 1. So yes, that's good. So we do need to have 4 R's and 3 L's. So that would be the case for any parts. Okay, so 4 R's and 3 L's. And so what shall we do? So we need to, from the 7 letters, we need to make arrangements. So for these 7 positions, right, 1, 2, 3, 4, 5, 6, 7 positions. So we need to select 3 positions to be RL, right? Then how many ways are there? That would be 7 choose 3. choose 3 out of 7, and so there are 2 notations. This is not the Chinese notation, this is the US notation, and no matter what, and the number would be just 7 times 6 times 5, and over 3 times 2 times 1. So I don't have time today to explain the combinatoric numbers, but that is the combinatoric numbers formula, and then you cancel out, you get 35. So you know there are at most 35 parses. Okay, so you see, oh, that's kind of like coincides with E, but you need to see, is there any other restrictions in this picture? And what do you see is actually you do see there are some restrictions. Why? Because you cannot go R, R, R again. You cannot go 3 R's. Then you would walk out of the checkerboard, which is not allowed. So you know that the numbers must be less than 35, but you still have 4 numbers to choose. So then what shall we do? And for me, I kind of got stuck here. So I don't think, because then what I need to do is I need to exclude all the possible parses that goes to here and then go back to R. But it's not that easy to calculate. So then I give up. So after I give up, what I do, so I see if I could have any other method. Then suddenly I notice one thing. What that thing? Which for this part, yes, essentially it's about L and R, right? So I can denote this by a line segment with arrows, right? It either goes left or right and something like that. And then I thought about a question that was appeared in the book that I wrote 20 years ago, which is this one. So from A to B, how many parses are there? So with, of course, you can only for each line segment you can only go according to the arrows. Then for this question, what is the tricky? What is the nice method? The nice method is you just count how many ways you can go from A to any particular point. For example, there's only one way you can go from A to here, right? But to reach that point, you have 2 ways. 1 and also here, 1. So this is 1 plus 1, so you have 2. So how about the number of ways to achieve that intersection point? You can either go from left or you go up. So it's 1 plus 2, that's 3. And then how about that? That would be 2 plus 3, that's 5. So this is what actually is a Fibonacci sequence. 3 plus 5 is 8, 5 plus 8 is 13, 13 plus 8 is 21, 21 plus 13 is 34, 34 plus 21 is 55. Okay, so once I notice that, of course, that is here in my mind, and then I can come back to the original question. And for the original question, what I can do, I can just use the labeling method, so the numbers to label each possible parses in the wide squares. So how to do the labeling? So we can do it 1 by 1. So what do I mean? Do it 1 by 1. So how many ways you can go to P from this wide square? There's only 1 way, right? And how many ways you go from here to there? There's only 1 way, because in this row, you can only either achieve this wide square or that wide square, no more, right? And then how about the next row? The next row you can go further left, so there's 1 way. But for this cell, you can either go this or that. So there will be 1 plus 1, so that's 2. And so that's 1 again. Okay, so now we go to the next row. 1. So here is 1 plus 3 is 3, and here 2 plus 1 is 3. So you see, if you have ever heard about Pascal triangle, this is very similar to Pascal triangle, but not exactly the same when you see the next line. Why? Because it's 1. 1 plus 3, that's 4. 3 plus 3, that's 6. But then 3, there's no 1. There's still 3. Okay? So then what next row? 3 plus 6, 9. 4 plus 6, 10. Okay, 10 plus 9, 19. And here we have 9, right? You don't really need to worry about that because that cannot reach Q. So in the end, you have 19 plus 9, that is 28. So once you figure out the method, the calculation can be fairly quick. But of course, in a sense, it's challenging because as averagely you only have 96 seconds to solve each question. So you have to save some time from the beginning question, so that you maybe for such hard question, you may have 3 to 5 minutes to think about it. All right, so that's 21, and now let's move on to the next one. The next one would be 23. And so this year, the AMC 8 question is slightly different than previous years. Is normally there would be maybe 1 or 2 probability questions which are relatively hard, but this year the hardest part question, the hardest counting and probability question is really a counting problem, which is this 23. And for this 23, for me, when I see this question, I feel very happy because I know simple as I saw this similar type of question probably like 20 years ago. And so how to solve it? So 5 different awards beginning to 3 students. So when I see the first sentence, in my mind, I have an additional word added up to that. Of course, this is a useless word. I see 3 different students, and every 2 persons are different, so that's a useless word. But mathematical speaking, it really illustrates something. Okay, every student receive 1. So we have 5 different objects that allocate to 3 different students, or you can think students as boxes. So these are the questions. And so to make the situation slightly easier, so what I'm going to do is I'm going to change the condition to a similar, easier one, and I change the 5 different words to the 5 identical words, or the same word, and I assume that the 3 students are the same or are identical, right? And see what's the situation. So then that becomes clear because 5 identical words is just like 5 apples. So allocated to 3 boxes, 3 identical boxes. So you have to. That means you need to split 5 into the sum of 3 numbers, and the order does not count. If the order does not count, so there's only there are only 2 possibilities. It could be 1 plus 1 plus 3, or it could be 1 plus 2 plus 2. There's no more because each element has to be at least 1. So there are only 2 cases. And then what's next? Then what's next is you can change the order because actually there are 3 different students. So you can change the sum out of the order. For this 1, 1, 3, how many ways you can change? You can, it depends on where you put the 1s. You can change into 3 plus 1 plus 1. You can change into 1 plus 3 plus 1. So there are 3 ways. Similarly, for 1 plus 2 plus 2, there are 3 ways, right? It could be 2 plus 1 plus 2. It could be 2 plus 2 plus 1. So that's it. So if we change, so that means if I change, so I first think that they are identical, and then I change. In that list, I do consider the situation that they are different. The students are different. And now the last step is I need to consider for each kind of like the split. This split actually tells us how many words that each student get. And then for each cases, for each scenario, I need to see how many, if we have different words, how to allocate according to this amount. And then that would be what? That would be something called combinatorics numbers, right? You select a certain number of objects from all the possible objects, right? And then, so we have to use the combinatorics numbers again. So let's see this case. So 5 different words. So first, how you allocate? You first can select 3 words for that person who gets 3 words. And then there are only 2 words left, and you can select 1 for one person, and then the remaining 1 will be for the other person. So for each of these cases, you have that number. So 5 choose 3, and then 2 choose 1. And then the result is actually 10 times 2, that's 20. And then for this, so first you can choose 2 words for one person, and then choose the other 2 words from the remaining 3 words. So that is again, that is 30. So in these 3 cases, you have 20. In these 3 cases, you have 30. So the final answer would be 3 times 20 plus 30. 3 times 50, that is 150. So that would be B. So that is the correct choice, right? So of course for this one, because you need to use combinatoric numbers, and maybe if you are not familiar with that, you need to find a textbook and learn it. All right. So I think probably we have one more question left, and then we can finish. And that question, although it's very difficult, but this question, among all the 8 questions we discussed, the solution is very short. Okay, so this is called the Flippy number. Flippy numbers is that the only 2 digits appear and they're alternating. So if you form by a format, it would be something like A, B, A, B, A, right? It must in that format. And then it says that this is divisible by 15, right? So how to deal with that? So 15, and we definitely know that 3 times 5. So that this number has to be divisible by 3 as well as by 5. So this number is divisible by 5. So what does it mean? If it's divisible by 5, the rule is the last digit has to be either 0 or 5, right? But you see, the question is nice in the sense that it cannot be 0. As if this 0, this is 0, and here the leading digit is 0. That is impossible, right? So the last digit has to be 5, and not only the last digit has to be 5, the number has to be in that form, 5b, 5b, 5. So this is a multiple of 3. It's divisible by 3. And in order for this number to be divisible by 3, so what does it mean? The sum of digits has to be divisible by 3, and you add up the sum of digits, 5 plus 5 plus 5, so that's 15. That is already a multiple of 3, and then plus 2b. So 2b has to be a multiple of 3. Then this just means the b has to be a multiple of 3. So here a bar plus number means it's divisible by that number. So b is a multiple of 3. b is a digit. b is a digit. So what could be the case? So b could be 0, 3, 6, 9, nothing else. So B is the correct answer. Okay, so let's finish the question explanation. And so next page, I'm going to show you something. Hopefully you will feel funny. So that is my AMC8 certificate back 30 years ago when I attended the so-called AJHSME back in 30 years ago in Beijing. And so what is AJHSME stands for? So actually it stands for American Junior High School Mathematics Exam. And so that is the former name of AMC8. So around the year 2000, because the first AMC, which is only applied to high school, which is called AHSSB, American High School Mathematics Exam, so was started in 1950. So around 2000, we do have 3 levels of examinations: AMC8, AMC10, and AMC12. So that's why we have the new names. And of course, I think through this information, if you are clever enough, you should be able to identify my age. And so that is AMC8 certificate. And so the next page would be the AHSME, or the former AMC10, the former AMC12 award, and that is for Amy. And of course, I hope many students students that attend today's session can no longer attend AMC 10 and 12, well, but can also be qualified for the American Invitation Mathematics exam and maybe more. And maybe you can, like the person who got the full marking this time, that you can go to International Mathematical Olympiad on behalf of Hong Kong or Macau. And so I think we are about to end this session. So finally are some contact informations, because I'm helping the Mathematical Association of America to organize AMC in Hong Kong and Macau. So if you have any inquiries, you can send emails to me. And we also have an official account in WeChat, which you can find and get the latest information. And the next year's this academic year's AMC 10 and 12, which is 2021 AMC 10 and 12, will be arranged in early February. And we also have a discussion group that you can scan the barcode and try to join. All right, so that's all for today, and hopefully through the AMC 8 activities, and you do feel that mathematics is interesting, and you do see your talent in mathematics, and have a good evening, and see you later. Bye-bye.